Okay, cool. This session is Design, Print, Build Code. My name is Anthony Russell. You can follow me at .NETRussell on Twitter. If you want to tweet during the presentation, please feel free to. Just make sure that you're using hashtag M3Conference or at M3Conference when you do that. They asked if that we would show the sponsors prior to the presentation. So these are the sponsors of M3 this year, and please make sure to check out their booths outside. If it weren't for them, we wouldn't be here. So, who am I? Anybody know who this is? This isn't. I swear this is not a picture of me. Yeah, it's Nikola Tesla, right? I am not Nikola Tesla. And more importantly, though, I am not an electrical engineer. I don't know who this guy is. I ripped this off of Google. But more importantly, I'm also not a 3D designer. What I am, come on in. That's all right. Come on in. What I am is a software engineer by day. Is anybody else in here a professional software engineer? Just curious, raise your hand. So do we look like this when we're at work? Do you look like this? No. I look like this when I'm at work. Usually, this is actually any given day. And if this had sound, you'd probably hear a bunch of F-bombs. So, yeah, that's what I do. This is me. My name is Anthony Russell. I'm a software engineer. I work at Highland Software. Has anybody heard of Highland Software? I'm a framework engineer there. I help build the framework controls for our department, so our engineers can build on base. If you are interested in Highland, I suggest you go check them out. It's a great company to work for. I've been there for almost 4 years now, and they were nice enough to let me come here today and speak. That being said, the opinions that I express in this talk do not reflect the opinions of Highland. This is my session, and I was in the Army for a bunch of years, so I tend to be following out the opinions of Highland. So, so that's what I do during the day. At night, I tend to spend a lot of time with Windows Phone, the Windows platform, and I do a lot of Arduino and 3D printing. So that's kind of how this talk came to be, is my hobbies, what I do in my free time. And you're going to get to see a bit of that today. So like I said, you can follow me on the Twitter, at .NETRussell. You can also see my blog, .NETRussell.com. I post a lot of the cool projects and tools that I work with on there. On that note, I am going to mention a ton of tools today. Nobody's paying me, just so you know. Like I'm here. None of the companies that I mention on here, like Saley or any of them, I'm going to mention Mayo. Like none of them gave me anything to mention their names. I use these tools because they're good tools. I use them because they work well. And that's what I've seen other professionals use and hobbyists use, so that's how that came to me. So, the story of how we got here. Does anybody here work with Arduino? What's the first project you do? You blink the light, right? Yeah. Everybody, that's what you do. It's the hello world for hardware. That's how I like to think of it. So that's what I did. I was interested in Arduino. So I started out with Windows Phone. After I got into the Army, I was not an engineer in the Army. I was a police officer. And I got out and I said, you know what? I really don't want to be a police officer anymore. This is hard work. I want to do something where I can sit on my ass all day. So I decided to get into programming. So I used my GI Bill and I went back to school and I got a degree in CS. And yeah, so I spent a lot of time with software. Well, maybe I'm bi-curious, right? So I started looking at engineering, at hardware. So I looked at Arduino, and that was kind of like my way into what I'm going to present today. So I went out and I bought an Arduino starter kit. I don't know if you've seen those or not. They're a pretty good deal, and I highly recommend an Arduino starter kit just because it has a ton of stuff in it that you don't usually think about that you need, like wires, resistors, things like that. Everyone thinks, oh, I'll just buy an Arduino and then I'll start hacking things. And then you realize really quick, well, I need buttons, and I need resistors, and I need LEDs, and I need potentiometers, and I need all this other crap. So the starter kit, it's a pretty good deal usually. I've seen them from $50 to $100 or more, and they come with a ton of crap. But most importantly, they come with a little book in the back that tells you a bunch of projects that you can make. Once I got away from that book, I started advancing into my own projects. And this is one of the first ones I did. Who here has ever had a car keychain that the buttons stopped working on it? Like, yeah, like that's a common thing, right? The buttons, they stop working on your car keychain, and we throw them away, and then we have to pay a lot of money to replace them. So I instead decided that I wanted to try and hook an Arduino up to it. So I did. I took it apart, and that little guy is what's inside, and I soldered some wires to it. Well, first actually what I did was I looked at the output of the buttons. I started hooking like multimeters up to it and seeing what each contact point did, and yeah, I kind of figured out that certain contact points went with others, and when you passed the voltage through them, it made stuff happen. And the car unlocked or locked or set off the alarm for an hour, and then I had to figure out how to like turn it off, and that was fun. This is a video of it. I don't think you're gonna be able to hear it. I don't think we have any sound. But what I can tell you, maybe I do. Let's see here. Does the sound work in here? Do we know?
It does not.
Does not. Okay, so I'll just narrate for you. That's fine. So I'm a big Windows Phone guy. So I had my Nokia there, and the reason I mentioned this project, I've done a number of Arduino projects. I won't go through all of them, but the reason I mentioned this one in particular is because this is the first one that I actually worked with Bluetooth with, and Bluetooth is actually a big part of this project that I'm going to talk about today. This little flashing thing over here, that's the Bluetooth card. It's really easy to work with. There's a serial library built into Arduino. You just new up a Bluetooth serial object and you tell it the baud rate, and then you can read from it. It's pretty easy. What wasn't so easy was the Windows Phone. Nokia was nice enough to make a free, open Bluetooth library that we can consume on the Windows Phone. I still use the same one today, and it's real nice. It makes it real easy for communicating with the Arduino. And what I do is I just send a command to the Arduino to connect, and then I send a command to either lock or unlock. And all that looks like in the code is just maybe a number. I just send one byte or whatever, or a 2 or a 3 or whatever. And the Arduino deciphers that and then sets the digital pins on and off, and that's what shoots the car off. And as I was doing this, my alarm was actually going off outside, but you can't hear it on the video. So I moved on to the next project. So this is going to look weird at first, but I promise you, no dogs were hurt in the process of making this. So I needed a camera to watch my dog while I was at work. And you're probably saying to yourself, but Anthony, why in the world would you want to watch your dog while you were at work? Meet ISO. He's known as the destroyer in my house. ISO is playful, and ISO's fun. ISO's a very good dog. Just kidding. ISO likes to rip nose-sized holes in my blinds. ISO also likes to somehow chew up documents with a muzzle on. Don't know how he does that. He also likes to create second dogs entirely by himself. That's a pile of fur that's about the size of him, if you can't tell. Just a sidetrack, when I comb him, I comb until my arm gets tired, and then I stop, not until the fur stops coming off. Just in case you're curious about getting a husky, don't. So the main reason I needed a camera, though, it really doesn't have to do with that stuff, because I get to find out what he does when I get home. The main reason I needed a camera is because ISO hates his cage. That's a steel cage that he would stick his nose through to bend the bars, and then he would bite the bars, and then stick his nose through to bend the bars, and then bite the bars, and kept moving back and forth. He eventually broke the cage. He broke through the steel bars to the point where the only way to fix them would be to weld them back together. So I don't put ISO in a cage anymore. That's the long and short of it. So I started video recording him because he was getting out of his cage. I didn't know how. This cage, it has two little latches on the front, and I was zip tying the latches shut, and I would come home, and the cage would be sometimes be open, sometimes be closed, and he'd be walking around my house destroying things. And I was totally baffled by this. I'm like, how is this dog doing this? So I set up a camera one day, and I recorded him escaping from his cage. Now, I'm not a horrible owner. There was a plastic mat underneath him. He kicks it out, and then he starts pen testing his cage. He puts his paws through and doing all these different things to escape. This is where he's breaking the zip tie on the latch and opening the latch, the top latch.
Wow.
And then, wiggling his way out.
Yes. That's gonna hurt.
I mean, like, you can't make this up, this thing. Like, and now he's out, and he's walking around my house prepared to destroy things, right? So, there was no more putting ISO in the cage. That wasn't going to happen. It's like standing in front of a wave and trying to stop it. I decided just to roll with it and try and figure out a way to beat him. So, I came up with this. This is just an Arduino, and there's the camera, and it's hooked to a servo. So now the camera is panning around my apartment, and I can watch it and walk around the apartment. What I ended up doing was, I'm a WPF developer, so obviously I'm going to write some type of application. I wrote an application that let me control the servo from work. So I would log in through TeamViewer, open up the camera app so I could see the camera app, so I could see the camera, and then I would open up my application that would control the Arduino over serial, over USB, and I could pan the camera back and forth to watch ISO walk around my house. Excuse me. So that's how I took care of that problem. I actually did a few more projects with ISO. If you're curious about it, hit me up after the camera's off, and we'll talk about it then. So fast forward a few projects. Meet Troy. Troy in my house is known as Destroyer number 2. This is my son. He is a great little boy. He just turned 7, and I love Troy. Troy likes to build stuff, just like Dad. Troy can also blink an LED, just like all of us. Troy wants to be an engineer, just like Dad. And what's one thing engineers are really good at? Breaking stuff and putting it back together, right? Unfortunately, when Troy breaks things, he doesn't do it with the intention of putting them back together. So that begins the genesis of the Arduino RC car, which you're all here to see. Troy had an RC car very similar to this one. And apparently this RC car, when they made it with a one-off remote control that could never be replaced ever in the entire planet. No matter what hobby shop I called, no matter who I spoke to, no matter what data sheet I found, you could not replace this RC car's remote control. It wasn't happening. The advice that I got from everybody was, buy a new RC car. Well, that meant Troy had a useless RC car. But Daddy had an Arduino. So, of course, I ripped the RC car apart and I hooked an Arduino up to it, because that's what we do. And this is the initial test of it. So, what you're seeing here, I promise you the sound for the video isn't all that great, it's just the car going back and forth. This is an Arduino Uno, and I have a motor shield, an Adafruit motor shield hooked up to it. And then I have the front motors of the RC car. Actually, real quick, does everybody know how these motors work? I don't know if you know or not. So, the way these motors work is when you pass current through it in one direction, the wheels will either spin or they'll turn left, and then when you pass it in the other direction, they'll spin in the opposite direction and then turn right or whatever. So it's entirely based on the direction of the current. So, and that's what the motor shield does. The motor shield allows you to pass current in both directions. You can't do that really with your Arduino. You would need some extra equipment to do that. And also the motor shield allows you to pass large amounts of current. The Arduino limits how much current it outputs through its pins. So the motor shield, I was able to hook the RC car's 9.6, I think it was 9.6 volt battery up to the Arduino directly, and it just pumps the current right into the wheels. So that's what you're seeing here. I have the front motors hooked up into one motor on the motor shield, and the back motors hooked up into the other. And then I just have a program on the Arduino Uno running that's saying, drive forward, drive backwards, turn left, turn right. And that's it. You can see that my hasty power cable, that's, so that barrel jack, I love Scotch tape. I could probably put a child through college with the amount of money that I spent on Scotch tape. I use it for everything. When I'm soldering, I will take the wires and that, like the wire hooked up to my soldering iron, and I will, tape it down to my desk. So if I accidentally hit it with my leg or something, it doesn't go flying into my lap. One thing that doesn't protect you though is reaching over the soldering iron for a beer and then setting your arm on the soldering iron. This was a scarf from like 2 years ago, so don't do that. That's a bad idea. Soldering irons get really hot. So the next natural step was that I was going to hook my phone up to it. This is the same Windows phone from before, the same Bluetooth library and everything, and I wrote an app that sent some basic commands to the car that told it to stop, go forward, turn left, turn right.
So you're just using Bluetooth to communicate between the phone and the...
That's correct. Yep. Now I've advanced the Bluetooth library a little bit on my own. It was sending like 32-bit, commands. Didn't need to send that much. I reduced it down quite a bit, so it sped it up. Also, I don't wait for a response. That was one of the other things. I heavily modified it for this car. I think originally the library was expecting a response from the Arduino, which slowed down the communication. I don't need two-way communication. I just needed to stream out packets. That's it. Just stream out, hey, I'm pressing the forward button. Hey, I'm turning left. And then if they get to the car, great. If they don't, whatever. I don't care if it drops, because there's going to be another 50 coming right after it. So then this really cool thing happened. This company that I can't pronounce the name of their device. It's Mio, something like that. It's a Canadian company. Thalmic Labs is the name of the company itself. They sent me this really neat armband. Does anybody know what this is? Has anybody seen this? This thing's awesome. I don't know if you. I got the. I want to say I got the alpha version, so I got a really early version of this thing. It was real bulky. You'll see it here in a second. And what it does is it reads the electrical impulses coming out of your arm, and it's able to determine what position or what gesture you're making with your hand. So if I make a fist, it knows that. If I'm spreading my fingers or turning my wrist left or right or inward, it can determine all of these different things, all these different impulses, and you can use them. They're like events. So I rigged into that, and I hooked up to my RC car. So you'll see here, I'll make quite a couple gestures with my fist. So I see I squeezed my fist and it started going forward. Now mind you, this is a real early prototype, so there's quite a delay. A lot of these things I didn't realize starting out, but when you're debugging, I left a lot of my debugging code in there. When you're debugging with Arduino, you really want to take, or when you're done debugging, take your debugging code out because it'll slow everything down. Especially if you're doing like serial output, which is what I do for debugging, which is probably what most people do for debugging. The serial output commands, they take up a ton of processing time. And that's what you're seeing here. I'm like squeezing my fist and it's saying, squeeze detected, and driving forward, and like I didn't need that because clearly nothing's hooked up to it, so I should have just commented it out, but I didn't. So after that, the project died for about a year, and I didn't really plan on doing any more with it. I let Troy play with that car, and that was about it. And then I decided that I needed a 3D printer, and I really wanted one really bad, so I had to come up with an excuse. Now, mind you, I'm divorced. I had nobody to answer to but myself and my dog and my kid, but I couldn't just go buy a printer. Like, I needed to justify it. So I said, you know what, if I use this to build educational devices, then you know what, I can justify a printer. Because if you did read my bio, I do a lot of education in my free time. I work with kids a lot. I'm trying to work with Cleveland schools and things like that to teach kids more about CS, and I've been teaching HTML, CSS, and JavaScript for a couple years. I recently taught a Java class to some high school kids. So I work with kids a ton, and things like this, they really bring it home to the kids and shows them, hey, that stuff you're learning in math, it's not just crap. Like, you can take that physics and you can take that math and you can, turn it into X, Y, and Z coordinates for a car, and you can do some fun stuff with it. And I think that once you show kids that you can blow a hole in a wall with physics, then it's like, they really get it, they like it. So that's my tangent. I really like working with kids, so if you're interested in that kind of stuff, feel free to hit me up afterwards and we can talk. So this was the first printer that I bought. It was an XYZ Da Vinci. I don't want to say bad things about this printer. It's not a horrible printer. It's not a great printer. It's about middle ground. It's a great entry printer, entry level, and it prints in 2 colors. It's nice. You can do ABS and PLA. One thing I didn't like about it is that they have proprietary filament. Like, you have to buy their stuff. There's some hacks for it that, like, you can get an Arduino. I think there's one on Hackaday where you can reset the RFID chip inside the proprietary filament container or cartridge, and that way you can buy off-the-shelf filament and you just reload the cartridge. But like, 3D printing is so new and it's so open source, and like, everybody is building their own printers. There shouldn't be proprietary crap yet. Like, we should be able to just build a printer. So that kind of irks me. The other thing that bothered me about this printer was that it was huge, like huge, and it was cool that I could just take it out of the box and plug it in and it worked. The trade-off is that this thing is like 1,000,000 pounds. So I had to, if you're not familiar with the Cleveland area, Micro Center is on the east side, and I live on the west side. So I had to drive an hour to Micro Center, and I had to carry this giant box out to my car and jam it in my little Kia, and then I drive this thing all the way home, and I live on the 2nd floor, so I had to carry it up 2 flights of stairs, and I put it all together, and then I started printing, and it broke 7 days after I bought it. So, and it broke in a manner that, now I'm a pretty resourceful guy. If I could have fixed it, I promise you I would have fixed it. One of the Y-axis motors, there wasn't enough tension on it, and this is a steel box. So in order for me to rig it to have enough tension to where it wasn't slipping, I would have had to like drill holes in the steel box. It was a huge pain in the ass. So I was like, you know what? It's only been a week. I'm taking it back. So I had to carry this thing back down 2 flights of stairs, jam it back in my Kia, drive it an hour back out to Micro Center. It was horrible. So then I bought this, and this thing is awesome. If you get a chance to buy one of these, I would highly recommend it. This is called the PowerSpec Ultra 3D. This is the printer that I've been running literally nonstop since November. You can ask my girlfriend, it's always going, you can hear it all through my house, it's ridiculous. I love this thing. It's based on, so this is like the generic version, if you've heard of the company FlashForge. This is their design. I think Micro Center just kind of like bought it, stuck their sticker on it, and was like, generic. A little bit cheaper. This printer is awesome. It has Wi-Fi, it has USB, it has an SD card. The only downside to this printer that I have found is that their software that ships with it sucks. And I mean, it sucks bad. Like, the slicing software takes forever. And if you don't know what slicing is, it takes the 3D model, the CAD that you make, and then it slices it up into like 1,000,000 little pieces, and then you give that to the printer, and that's the layers that it does. The software that the PowerSpec printer came with really sucks. You can't add custom supports like in the middle, so if you're trying to print something, and like say for example, I'm like standing here, and I needed extra supports like from my shoulder to my head, like I couldn't add those in. You can only add supports from the printing platform up. Like, it was just bad news bears, don't get it. So instead, I bought this program called Simplify 3D. It's a little pricey. It's about $120, $130 I think. However, awesome software. Since I bought it, my failure rate, by the way, yeah, the failure rate with the software that this thing came with was like 50%. It was a horrible failure rate. With Simplify 3D, my failure rate went down to like 5%. I very rarely fail prints. If I do, it's because of something stupid I did. Yeah, it's hard to recommend that software enough. I know it's pricey, but it's well worth it if you're getting into 3D printing because the prints take hours. So when you print for hours, especially if you're printing overnight while you're sleeping, and you wake up in the morning to a pile of goo, you're going to be pissed off. The printer filament is not super expensive. I mean, I think I pay like 15 bucks for a roll. Like it's cheap. I run the cheapest crap through this, and it comes out awesome. So, yeah. All right. So those are the tools that I'm going to be using. The M series begins. So this is going to be a series of cars that I made, starting with the original one that one that we just saw. These are not cars that I made. These are some of the kits that you can buy from like Micro Center or Spark Fun. I think that's where I scraped these photos from. They range from $50 to $100 or more. And they're cool, but they're not really customizable. You can't mod them. Like I don't know, I guess I can mod that, maybe. It's got some holes in it, but it's kind of like you build the kit and that's what you get, you know? That one, it's got some spaces on it where I can add to it, but maybe I want the wheels to be further out, or maybe I want 2 wheels instead of 4, or whatever, you know? Like, it doesn't offer a lot of options. So I said to myself, you know, anybody can make a kit. I want to build my own from scratch, down to the bolts. So I had some objectives. The first objective was that it had to be totally designed and printed by me, because remember, I like working with kids. I want to show kids that even somebody like me, you know, dumbass, I could build this stuff with free information on the internet. It had to be easy to reproduce because, once again, I'm assuming people like me aren't trying to reproduce it. So it had to be easy to do. It had to be totally open source. I'm not a huge open source guy. I work for a company where we have 0 open source. You know, I'm all for profiting, but I like giving back to the community. I think that's important. I think, especially, we all stand on the shoulders of giants. You know, like I didn't write C or C#, but I use it all the time. So I feel like it's important to feed back into the community and help build the next generation. So I definitely wanted this to be a totally open source project. It had to be modular. That's one of those buzzwords that we love, right, in engineering. It had to be modular, whatever you think that might mean. So we start with the M1. The basic hardware, I'm not going to talk about the hardware all that much because it doesn't really change. The hardware, I came up with this design with that original car, and I kind of stuck with it because I like it. The Windows Phone is going to communicate to the Bluetooth chip that we saw. The Bluetooth chip is plugged into an Arduino FIO. Now, you'll notice that I have 2 Arduinos on this project. One Arduino is my communications layer. I use it for more than just communications, though. It can be used for other peripherals. We could be running a camera or sensor data, whatever. And it's right there on the communication layer, so it can easily be transmitted back and forth. And then I run the mechanics, the motors, off of the Arduino Uno underneath that's hooked to the motor shield. I did this for a number of reasons. One, I wanted the separation of concerns. I wanted my logic and stuff up on one layer, all the processing to be handled up there. And then I wanted the Arduino Uno underneath to only have to worry about the motors. I didn't want it to be like processing accelerometer data so the car slows down or something silly like that. I mean, if you're going to see that serial output slows down processing, could you imagine if I was doing like 20 or 30 things? It wouldn't be good. So I separated them out, and this design works really well, so I decided to stick with this.
Is your motor shield designed for 4 motors?
Yes, the Adafruit motor shield, which I can't say enough good things about this. This motor shield can handle 4 motors pretty easily. It can also do servos and all different types of stuff. It is a great shield. It's more than just an H-bridge. An H-bridge, for those that don't know, that's the thing that sends current in 2 directions. It actually has a number of H-bridges on it, I think, which allows it to handle multiple motor controls at once. the way that I have mine rigged up is, you'll notice here I have 4 motors, but 2 of them are plugged into one motor port and the other 2 are plugged in the other motor port. The reason I did this was because I said, well, the left wheels are always going to be going in the same direction and the right wheels are always going to be going in the same direction, so why overcomplicate things? Just hook them all into the same motors, then I only have to manage 2 motor objects in code. Oh, by the way, that was the, I don't know if you've heard of this program, it's called Fritzing. This is a neat little program, you can do sketches and stuff on there, it's free. I slapped this thing together for this talk. This is pretty much how it looks. The Arduino Uno and the motor shield are stacked. They're hooked into the motor controls. There's the FIO hooked into the Bluetooth. And then the only thing that's not accurate on here is the battery. I have a 9.6 volt RC car battery hooked up to mine. These are AA's, so like that's not the same. But everything else is pretty much the same. And I have the car up here at the end if you guys want to come see it, you can come take a look. So now for the code. Yeah. I'll try and go quickly through this. I know we all love looking at code on PowerPoint slides. So the communication layer, I just managed one Bluetooth object. So back up real quick. The Arduino, there's 3 main parts to it. You have your variables. You have your setup function, which runs the first time you plug the car in, or not the car, but the first time you plug the Arduino in, the first time you power it, you get your setup function. And then after that, setup function doesn't run anymore, it just loops forever while it's powered. So in your setup function, that's where you want to initialize your pins and things like that, initialize your objects, and then in your loop, you're running conditions over and over and over again. So in my communications layer, in my setup function, I initialize my Bluetooth object, and then I set my 4 output pins, and then in the loop I say, hey, do I have a packet? Do I have a packet? Do I have a packet? If I have a packet, I see what number is in there, and then I run the appropriate functions. And here's my setup for the communications layer, the Arduino FIO. You can see I initialize the Bluetooth, and then I set my 4 output pins. The output pins are what we're going to tell the motor control what the user is selecting with. So I don't know what order these are in because I didn't put the enumeration up here, but one of these is forward, one of these is backwards, one is left, one is right. And then at any given time, one will be high and the rest will be low. Because the pins, it's binary, it's either on or off, right? So when I say high, I mean on. When I say low, I mean off. And that's what it does. And then this is the loop. So I run through, I read the Bluetooth serial command. I check to see if there's a packet in there. If there is, I flush the Bluetooth out. Make sure you do that or you're going to have a bad time. I flush the Bluetooth out and I take the command and I check to see which one it is. It's pretty straightforward. If anybody's seen code in here, this should be pretty simple to you. And then these are what the functions look like. The go forward function, I just set the other pins to low and I set the forward pin to high. That's it. Same thing with the go backwards. I set all the other ones to low and I set the backward pin to high. Note that the serial print line is commented out. That's key here. Note that that's commented out. You're going to want to do that. So the mechanical layer, there's 2 motor variables, and then in the setup, I initialize the motors and I release them, and then in my loop, I check to see which pin is high. So note here that the serial is not commented out, and it does affect it. You'll see that later. So the left motors, I set the speed, the max speed for them, and I tell it to release. Release just means stop. The right motors, I do the same thing, give it its max speed, and I tell it to release. And then in my loop, I just read the pins. I say digital read. If it's set to high, then run that function. Else if, else if, else if. And then finally, for actually turning the motors on and off, I really hate, this is the only bad thing I have to say about this motor control. Forward and backward does not mean forward and backward. They should have used some other arbitrary name, but this is probably the thing that will frustrate most people with these. You're going to plug your motors in, and you're going to say, run forward, and the motor is going to go backwards. You're going to be like, oh, why is it going backwards? It's because forward doesn't actually mean forward and backward doesn't actually mean backward. It's just an arbitrary value they assign to the direction that they're sending the current. I don't know, I mean, they could have used any other words, that would have been great, but just so you know, if you're trying to get your car to go forward and you put forward in here and the car actually drives backwards or whatever, just switch the wires around. You'll be happy. All right, so on to the actual prints. This is the M1. This chassis was never actually printed, and for good reason. This is the first time the motor mounts appeared. I designed these. The motors slide down into them, and they clip in. And then the Arduino was supposed to sit inside here, and then it was supposed to just like push that little nub forward. And the reason I came up with this design was because I was too cheap to buy 4 motors. I only wanted to buy 2, but it didn't work. So rule number 1 of 3D printing, respect thy support material. That is why this did not print out. Support material is what holds up your print as you're printing. There was no way I could print this without a ton of support material. This never made it to the printer. Because it would have just taken a ton. So I went back to the drawing board and I said, okay, I need a modular design. I need to build the motor mounts separately, which means that I need some way to fix them to the actual chassis. I didn't want to use glue, I didn't want to use tape. That meant I needed to get clips or pins or something. And remember, I'm building everything myself. So I did the natural next thing. I went to Google and I found this MIT class, mit.edu. They did a class on snap fit joints and push pins. So I started reading through that, and these are some of their designs. They go in nauseating detail about clip design, sizes of clips, angles, filaments, the amount of pressure you can put on clips, the length of the clip, etc., etc., etc. I didn't do all that. I just kind of made clips and see if they worked based on their designs. I actually used quite a few of these in testing. We'll see a few of them. That was the first one up there. It was a push pin. It was just supposed to push in. This one actually is a hook. It was supposed to go in and hook in. That sucked, so that never got really off the drawing board. This U-shaped snap, I actually used this in a couple prints. It ended up sucking. And then this T-slot I used also. So then on to the M2. The M2 was quite an improvement over the other one. As you can see, the motor mounts snap in. Unfortunately, during testing, it became apparent that the snaps didn't really work that well. They were too loose, too flimsy, so the wheels were like all over the place. So this never really got off the ground. And I moved on to the M3. By the way, I have an Iron Man like fixation, so that's why everything is M. You know, sorry, it's the Mark III. You know. So I didn't like the original clips that I did on the M2, so I moved on to using that U design snap. As you can see, I put in the snap points on the corners. I made sure they were evenly spaced, everything was the right height. This actually got printed, but once I printed it, it became painfully clear that when you apply weight to the top of this, the U-shaped snaps bow outward. And that wasn't apparent in the design process because the designer, the CAD that I use, doesn't incorporate physics. So I had no idea until I printed this out, and I got it all put together, and I was like, oh, that's so cool, it works. And I started putting the hardware in there, and it bowed out, and I couldn't even drive it. Like, I was so wrecked. Because, I mean, you're looking at, like, probably 15 hours worth of printing, so it's like, on to the next. So the Model 4, I said, all right, enough with the clips, let's use some bolting design. So I came up with this, I call it a gravity bolt because if you turn the car upside down, the bolts fall out, because I held in by gravity. So I used this mounting system. This actually worked really well. It created like a rigid body. It kept the wheels pretty straight. I had to tweak it a little bit, but the mounts went in there pretty well, and I used this design for quite a while. It worked by pushing the mount actually into the chassis. That was like a friction thing, and then I pushed the bolts in, and it held together really nice. So I was able to solve other problems now, and I moved on to how I was going to fix the Arduino to the chassis. The first thing I used, I don't know why, I'm a glutton for punishment. I went back to those U-shaped snaps the first time, and I tried to use the U-shaped snaps to fix the Arduino to the body, but it wasn't happening. Like, it didn't work. They wouldn't clip in. It sucked. So on to the next one. The M5. For the M5, I used the same mounting for the motor mounts, and then I started using the T-slots to push the Arduino on and slide it in, and this worked. This worked actually pretty well. The M5 was the first one that I printed out, coded, and actually drove. So here's early testing of it. Let's see it going here. So this one actually worked. So I put it on the ground, and I let it drive across the ground because that's the natural next step. And it worked pretty well. So we got a working car, finally, right? It only took me 5 iterations, 5 different models. I finally got something on the ground and running. So the next thing was to rework the Windows Phone app. I didn't have to rework it too much. It's pretty simple. It's just a couple buttons that you can drag your finger across. I wanted to make sure the app was kept as simple as possible because I remember how it was starting with the Windows Phone. It can be kind of intimidating, so I wanted to make it just so people could just like pick it up and go. So there's the app, pretty simple. And then I gave it to Troy, and I let him drive it around. And now you'll notice this is the M5, and you can see that the battery is actually hanging off the back of the vehicle. Probably not the best idea. Now, you're thinking, why did you do that? That clearly doesn't make sense. Well, because I have an Iron Man fixation and I wanted to have M5 on there, and clearly M5 had to go in the center of the chassis, so I couldn't have a battery pack over top of the center, because then that would cover up the M5. Like, no brainer, right? Unfortunately, this caused the car to do wheelies a lot, like when you would drive it around. And like things would shake around, and it made it unbalanced, and it would turn in weird directions. So the car was good, but the weight distribution was bad. The code was lagging because of the serial output that I didn't realize at the time. So we're on to the M6. Now the M6, I decided that I could, put the M6 in the front so I could make the battery in the center. I kind of took that hit. And as you can see, I'm back to the U-shaped clip design, because I'm, once again, a glutton for punishment. That broke immediately, by the way. That didn't work at all. As soon as I clipped that on, the things just snapped off. So I think that's the last time I used those. I hope so. This is what the M6 looked like when it was all put together. Note that the battery's over the center. Unfortunately, so this worked, this got printed, and I used this actually, I put this on Hackaday. When I got this printed out and put together, I was like, oh, this is the final one, right? I can just improve from here, just mod it a little bit. But when I took this to a couple different events, like a hackathon, and started driving it around, when I would turn, it would send the battery flying off of the car because the battery wobbled in there and it was in the center, and it just was a bad design. So you can see it sliding around a little bit here. This is the actual M6 that I built. I chased my dog around the house with it a little bit. It was a pretty fast little car, but unfortunately, you can see the equipment wobbling back and forth every time I hit the accelerator. And I wish I would have gotten it on video flying apart, because I hated recording my mistakes. Eventually I got to the point where I started recording my mistakes because it's funny to show in presentations, but I didn't feel that way at this time. So I didn't record the death spin that sent everything flying apart. In hindsight, I probably should have, but that's the M6. So on to the M7. The M7 is the ugly child. I don't like this one. Rule number one, right? Respect thy filament. This was a horrible design. I'm not afraid to say that. This was horrible. When I printed this, it had like 1,000,000 pounds of support material. It was hard to get the components in there. This actually was so bad that when I built it, when I went to take it apart to like get the components out, I actually broke most of the components. I had to rebuy a lot of stuff. The solder points like ripped off, and it was just a shitty design, like horrible. But that's why we do this. We make mistakes, we grow. The current version, the M8. This one I'm really excited about. I worked really hard on this over the last couple months, specifically for the M3 conference. This gave me a great reason to revisit the idea and redesign it. So I said, you know what, I want a new design. I want it to be fully enclosed. I wanted it to print mostly flat. I wanted it to be easy to modify, like I want to be able to snap parts on and off. I wanted to have lots of cargo space for extra components, and I wanted it all to snap together. You know, you've seen my snap designs, they're not the best, so this was a tall order for the time that I had. I think we have like a month or something like that to build it. So it was a tall order. I had to redesign the snaps. So I went back to that MIT page and I started looking at the snap design again, and I experimented. I must have printed 50 different snaps, different shapes, different sizes. Like these look the same, but they're totally different because of the width of the snaps. I experimented with different sizes of the holes. If one snap worked better than two, or you know what. And I ended up coming up with a few different designs that worked pretty well. These are the sidewalls. This is the snap that I ended up going with, so you'll see it everywhere. The sidewalls of the car, the front and the back. This is early construction, early designs. This is not the final product. These ended up getting shaved a little bit, but that's kind of how it goes together. I'm back to using snaps again for the motor mounts in the early designs of the M8. That's key, early designs in the M8. This is how it all looked once it was in, well, this is early design of the inside the box. I wanted to see if it all fit inside there, so I just kind of threw it all in. And then, you know what, even after 8 models, countless prints, I've been printing these things since November. You know what, it's not so easy to get it right. As you can see, the wheels are like bowing out. You would think that I would be able to, you know, fix these things at this point, but yeah, no, that's what happened. And that was probably like 20 hours of the printing to get it together to find out that the wheels bowed out. So, kind of heartbreaking. But then we came up with this design where we had these little brackets in, and I moved the clips down. And you know what? It went together. It went together, and this is the first test of it. So you can see that the wheels are straight, and got the Arduinos packed in there, and it worked. For some reason though, I don't know if you can tell or not, but this wheel over here, it wasn't spinning at the same rate as everything else. It was kind of like starting to spin and then it would stop. So I could have looked at it in code, but that would involve, you know, putting serial debug points and all that stuff in there. So I broke out my logic analyzer. Has anybody here worked with this logic analyzer before? All right, good. I'm happy to be the person to bring this to you, because when I saw this, this was like a holy shit moment in my life. Like, you have no idea. This thing is awesome. This will let you, this is like a debugger for the physical world, okay? You can just take these probes and put them on contact points and then record on the computer. They have like an application that comes with it, and you hit record for like 10 seconds or whatever, and it'll record what's coming off of those contact points. If that isn't cool enough, say I'm trying to reverse engineer like remote control, for example, okay? I can hook this up to it, and if you hook it up to like a serial line that's like putting actual data over it, it'll decipher the data for you. If you're putting ASCII text over it or whatever, it'll say, oh, these bytes align to ASCII text or whatever. It'll say these are the letters, and it's really cool. This device is awesome. Can't recommend it enough. It's about $100. It's a little pricey, but I use it in like every project now. This is what the output looks like. Now mine are just square waves because It's just on and off signals. If I was passing data over it, we could do the analyzer over here, and it would tell us what the data actually was. Yeah, so this is actually what it's supposed to look like. I didn't have common sense to take a screenshot of when it was broken. This is the actual output from the wheels. This is the left wheel turning on, the right wheel turning on, the back left, the back right. I split them up so you could see which one was which. And when I did this, I noticed that one of the wheels wasn't turning on. So I tested the actual pin, and I noticed that the pin was turning on, but the wheel wasn't. So I was able to easily determine that the solder point was bad. That's not something that's easy to figure out in code. You might be looking at the code and be like, well, the code's right, it's working, it's turning on, why is it not working on the motor? You might determine that your motor is bad. You don't know. You could be totally wrong. So I used it to quickly figure out that my solder point was bad, and it saved me a ton of time. So with that, I fixed the solder point, and I was able to do my first impact test. I do impact tests with all my cars, just so I don't get out someplace and run it, and it make me look like an idiot because I run into a wall and it breaks into a million pieces. So I did an impact test with this one. Luckily, I recorded it because it was hilarious. My dog, I saw it, was like, what the hell are you doing? Don't let that thing hit me. So, yeah, didn't work out for me. Clearly, the clip design was a horrible idea because as soon as I ran into the wall, the clips popped off. I don't know why I didn't think that was going to happen. So back to using bolts. So the final design of the MA. This is what you're able to go and download. I posted this on GitHub just a few hours ago. I put it on Hackaday with instructions. It's on my blog, all the code, all the STLs. Everything is open source. I highly encourage everybody to go check it out. Print it out for yourself, mod it. I have a couple mods I'm working on right now for it. Like I said, I work at Highland. We shoot Nerf darts everywhere, so I'm working on a mod for the front of it to pop it off and put a Nerf dart collector on the front. It would be really easy to do. All I have to do is make sure my Nerf dart connector has the same clip design, and then it matches the width, and you can just clip on whatever you want. So this is the final design. It comes with a lid. I apologize. I tried to print this out in clear. I have a picture of how I printed it out in clear. It doesn't work for some reason. I don't have the right temperatures. I woke up in the morning after printing the chassis in clear, and it was just like a pile of goop. So I'm sorry, you only get a gray version to demo. So this is what I printed. You can see that there's a lid and that the motor mounts slide through inside. I designed this specifically for M3. This is the most complete design I've made to date. The car features 10 separate pieces. They all snap together and it creates a very rigid frame for the car. All the chassis pieces can be printed flat, which is, if you've done any 3D printing, this is really nice to be able to print things flat. You don't need any real support material. The only support material you need is a little bit on the chassis and a little bit for the motor mounts. The car can be printed totally enclosed. I didn't get time to print a lid, but the lid should work. I don't see any reason why it wouldn't, famous last words, but if it doesn't work, fix it and send it to me and I'll add it. The motor mounts fit snugly against the side of the vehicle, and we'll see here in a second that that's really nice, the way that they connect. And the components fit comfortably inside of the vehicle as well. So this is what it looks like blown out. These are all the individual pieces. You can see here the sides, how they clip on to the chassis at the base. You would clip the chassis is one piece right here in the center. And underneath these motor mounts, where the motor mounts bracket in, you can see that that's where you need a little bit of support material. And then I usually print these motor mounts standing up, so you would need a little bit of support material for the brackets themselves. It's not a ton. You can see that, so first you take the chassis and you clip the sidewalls on, and then you clip the front and back onto these sidewalls, and then you put the motor mounts in, and then you slide the bolts in. And it makes a really nice rigid frame. You can spin this car all day and it's not going to come flying apart, which is really nice. And then the lid just clips into these holes on the side, and then I create a little nozzle here on the front that the lid can clip down on. So there is the new M8 chassis design. It's vented. I did this for a couple reasons. I noticed that my Arduino was starting to build up heat. So this adds a little bit of heat distribution as the car's driving. Also, it saves on filament, it saves on weight. It was a good design. It's not very flexible. I mean, it's flexible without everything connected together, but once you connect everything together, it's pretty solid. There's how it clips together. The motor mounts just slide in there. For this print, just for the M8, there were 64 separate for the M8 alone. And that doesn't include the ones that failed. There were quite a few prints for this. And then here is the final design actually running. Now, like I said, this is without the lid. But as you can see, it worked pretty well. Drives straight, and nothing comes flying off. So some parting thoughts for you. Nothing that you build and design yourself, like, it's not going to be easy. You're going to have to do it over and over and over again. It's just how this works. Stick with the problems. If I can offer any advice, it would be work through the problems, because every problem that I've worked through, I've learned a ton from it. Be ready to ruin your hardware. That's going to happen. If you're working with Arduino, eventually you're going to ruin stuff. You're going to see magic smoke, and it's not going to be fun. Like, it's just how it goes. And buying a 3D printer was totally worth it. So if you haven't bought one yet, I recommend buying one or building one. So I can take a few minutes. I don't know how long we have. Is it, time's almost up here?
5 minutes.
I have 5 minutes. If you have any questions, please feel free. I'll take Q&A down here at the front, so I don't want to keep everybody if you're trying to get out of here. But thank you very much for your time. I'll leave the resources up here on the board, so if you want to copy them down, feel free to. I think the only thing that I didn't list on here, nope, I did, Tinkercad. Okay. Yep, that's everything. Thank you so much for your time. I hope you enjoyed the talk. I'll be available up front.